Hello everyone, this is Mateo with arcade.dev, and today I want to talk about why we use the chat analogy when we talk about LLM contexts, why I think that's a mistake, and why, even though it's natural, a lot of what we do when we deal with LLMs and context engineering is to avoid the natural pitfalls of using a chat abstraction when we communicate to LLMs. As usual, I will start from the LLM box here in the middle, right? The reason why we like to use a chat analogy is that the LLM sits here somewhere in our app, and we need to put some text in and some text out of the LLM. And this is going to be normally the response, right? So prompt, response, and usually we have a loop back here into the conversation where we append the response to the previous prompt, and we keep appending to a long list of prompt and response, prompts and response, right? So this naturally models a conversation. But what's the problem with this? The problem, and I'm going to move this. The problem with this is that it begins, simple and well enough, user message, or actually we start with the system prompt. And here we say like, today is X date, the locale or the current city is, system, city. We have like samples and you have to do this and that. So that is normally, so that's pretty much how the system prompt goes. And then we have the user message, right? So the user now goes here and they say, hey, LLM, please do this for me. And this is going to be the task. Then we combine these two and that goes to the LLM and we get a response. It's going to be, here's the solution. But then maybe this is an hallucinated thing and it's like, hey, actually, I mean this instead of this or whatever. Actually, I mean this in uppercase instead of lowercase or whatever. And then, so this is going to be the system prompt is hidden from the user. This is going to be a user prompt, this as well. And this is an LLM. We'll have a long sequence of these, right? But what happens here, right? So the LLM is very good at predicting the next thing. So this essentially, at the end of the day, is going to be a prediction of this LLM, of this neural network transformer model, of what should go. And it's very good and it's trained with reinforcement learning, and all of the pre-training is, to get a lot of context inside. And there is a lot of context engineering that we know and we love to, make this so that whatever this orange box is actually useful to the user. But now what happens after, a couple of hours of conversation with the LLM, and then I have, I'm going to put here, this is going to represent many messages happen here. Long, many messages later, then I say something simple. Hey, tell me about the weather today or whatever, right? And then if I'm far enough from the system prompt, this date is very difficult to find in the context. So the system prompt is a special prompt that it has maybe a lot of knowledge about the world and so on. But because we model context as a conversation, this is not in the recent memory or the recent area of the conversation. And the LLM, because it's trained in conversations, it's also very likely to be more accurate about the kind of latest 10, 50 messages. But what about, 1,000 messages before? This is where this analogy starts to break down. And we, as users, don't really care too much because it's good enough for 99% of tasks, maybe. But as we add more memory capabilities mainly to the LLMs, we start facing like, okay, what it remembers about me or my personality or how I like to interact, it's kind of wrong and it's kind of hallucinating some things. And how do we fix that? So there are a bunch of techniques, right? So if, for example, we are reaching the limits of the context window, we have techniques like short-term memory. That basically means summarize the conversation before sending the context to the LLM. This works as a possible solution because we are essentially getting all of this because we need to make a summary, the LLM, and we can also use the LLM to actually summarize this, right? So before we address the specific user need, we take the conversation, we make a summary that is much shorter and much more condensed. The LLM is given a specific prompt to, pick the important details, remember the facts, all of this kind of thing. And so the short-term memory becomes, okay, I'm gonna forget a lot of the kind of, useless detail from this conversation and get only the important bits. And this works fairly well for long conversations and so on. Then we have long-term memory, right, which is a collection of facts, collect facts from other conversations. And this is a more complex use case, but is very, very popular in things like ChatGPT and now Cloud, that they will remember facts. And normally these are based on like specific keywords. You will say like, hey, this is important for me or whatever, or remember this and stuff like that. And the LLM will make a decision to maybe call a tool, an internal tool, to save that into their long-term memory so that the next time you open a conversation, they have some facts about you or whatever, right? But these two things, they have limits as well. Like, it's not free to have long-term memory. I am going to consume some level of the context to store this, or I need to put this into a RAG system, right? So that's another technique, which is retrieval augmented generation. So that means I need to force the model to retrieve relevant context before replying, right? And this is, I guess, a very good way to overcome the limitation of this abstraction, because at any point, I will say, okay, here's what the user wants you to do. Here's the previous conversation or a summary of it, and go ahead and, go get me some context. The problem with this is that it's not necessarily true that this message here is related to the original user request, or that the conversation has a topic in itself. If I imagine a conversation with a human, it's very likely that I will go through a variety of topics, and the messages that I sent at the beginning of the conversation may or may not be relevant to the current message. And the more difficult pattern of this could be, hey, I learned something about that other person or whatever, or the LLM learned something from me in the context of a different conversation that has nothing to do with this latest message. But that one fact here, that is important. So modeling that kind of dependency tree that exists within the conversation or within a very long conversation across multiple topics, it is not addressed by any of these techniques. Extension of this, which I really like, and I think that's going in the right direction, is called graph RAG. So basically this is retrieve relevant context before replying, but also store the knowledge in a relational graph. So what does this mean, right? So we have a knowledge graph. And in a relational knowledge graph, this is a different piece of it. That knowledge graph is a way to organize the context in a way that things that are connected and are related to each other, they all are close in the graph. So I can do a little bit of graph traversal over these nodes and get more relevant context. And each of these units, these messages in a conversation, they can contribute to that knowledge graph. If done correctly, I think like techniques like graph RAG are the way to go. They are a bit expensive in the sense that I need to be always paying attention. The way I design my app needs to be more sophisticated. But it overcomes this limitation of just modeling everything that goes to the LLM as a conversation. I've not even touched here the details about tool calling and all of the output and its structure. You can see that there is a lot more that goes into making effective use of LLMs that simply, this simple loop, right? And the loop is still essential, right? Because I think it's very natural to interact with something like this in a loop that naturally takes you by the hand, like maybe into a conversation analogy. But I think we need to graduate from that. And as agents become better and we have more sophisticated interfaces to agents, the conversation analogy will be less useful. We will need some other things. Like, I'm very excited about like ambient agents that they will need to bring context from multiple interactions that I don't want to call them conversations. I am still biased towards conversations myself because that's the main way I myself interact with agents. But I'm excited to see alternative UIs to conversations and LLMs. I am interested in what you think about my take on how we model context for LLMs. Do you agree with me? If you disagree with me, let me know in the comments. If you think conversations are the future for LLMs, let me know why you think that is the case. And until the next time, happy building.